Up until this point in time, we've only discussed batteries as being our source of electrical energy in circuits. However, most of the world's electrical energy is produced by generators. This topic, motional EMF, is the basic principle behind how electrical generators work. Now imagine we have a metal rod, a good conductor, with a length L, and a uniform constant magnetic field B that is into the screen or into the page you're looking at. Imagine this rod is moving to the right with a velocity v. The particles that are positive inside this rod will experience an upward magnetic force, Fb, using the right-hand rule. Remember, your fingers represent the magnetic field, your thumb represents the direction, the velocity of the positive charge, and your palm will be the direction of the force on those positive charges. So with field lines, your fingers pointing into the screen and your thumb pointing to the right, there will be an upward force pushing the positive charges to the top end of the bar at location A. Now, the electrons are the ones that are free to move in the rod. They would move in the opposite direction, going downwards, in the opposite direction of the positive charges. So the magnetic force pushes them downwards so that in the end, there will be a lot of electrons that will accumulate at the lower end, giving point B a net negative charge and point A a net positive charge. As opposite charges accumulate on both ends, an electric field will develop in the rod moving downwards from A to B. Eventually, an equilibrium is reached when the electric field builds up until enough force is equal and opposite of the magnetic force on the electrons in the middle. So the electrons that would be in the middle will feel an equal and opposite magnetic and electric forces on them, or the positive charges as well. So when an equilibrium is reached, the sum of the forces is equal to 0, and so the magnetic force is equal to the electric force. And remember, the magnetic force is QVV sine theta, but the angle between the magnetic field and the velocity is 90 degrees, so sine of 90 degrees is just 1, so that's why we write just QVB. And the electric field, if you recall, or the electric force is equal to QE, and we get this following expression. The electric field is equal to the velocity times the magnetic field. So between the two ends, A and B of this metal rod, there exists a potential difference. What is the magnitude of this potential difference, VAB? If you recall, the potential difference is given as V equals negative E times D. Since we're just looking for the magnitude of it, we'll drop the negative. Our potential difference V we call the EMF induced. The electric field we just determined as the velocity times the magnetic field, and the distance is the distance between the two ends of the bar, which is represented as L. And this is written on your formula sheet as EMF equals BLV. And this potential difference is known as the motional EMF. So as long as this rod continues to move to the right at constant speed, there will be charge separation that occurs at the two ends of the rod. Hence, the rod will basically behave as a battery. Now suppose that we put this rod on a metal U-shaped conductor. Hence, this metal rod that is behaving like a battery now can be formed into a complete circuit as it moves to the right. As it moves to the right, we'll have positive charges accumulating at the top end and negative charges accumulating at the bottom end. And hence this will act like a battery. So this would be the positive and this would be the negative. And current would be induced in the following direction through the circuit. So it would go counterclockwise. So basically, this apparatus is a clumsy way of making an electrical generator. I call it kind of clumsy because at some point this bar has to get to the end of the rail. The magnitude of the current that would be induced in this circuit is equal to the EMF divided by the resistance. Remember, V equals IR, and in this case the V is the EMF that is induced. And we have BLV, but in this diagram our L is represented with a W, and hence I've changed the L to a W. So it's BW times V divided by the resistance R of the circuit. So if this behaves essentially as an electrical generator, you might be thinking, well, where does the electrical energy come from? This rod is behaving like a battery, supplying electrical energy throughout the circuit, and a lot of that energy is being dissipated over this resistor R. Well, as you pull to the right with a force, you want to make sure that it's moving at constant velocity. So there must be a force acting opposite to your pulling force, that is this external force, to counteract it to make sure that you're going at constant velocity. That force that is opposing it we call the magnetic force, or the magnetic drag. Watch as you pull to the right, the magnetic force will be to the opposite direction and current will be induced in this counterclockwise direction. If you were to push the rod inwards, then now we would have the reverse situation and current would flow actually clockwise. Okay, I think you're now ready to attempt some problems.